All right, here we go again. On to section 3 now, compound inequalities, and we're talking about unions this time instead of intersections. Okay, and a union is just an inequality that uses the term or instead. Now there's a difference here where I can't write it as one inequality. It always will have the term or inside of it. Okay, now if we think back and remember back to the intersections, x was always both less than a number and greater than a number at the same time. Less than one number, less than the bigger number, and greater than the smaller number. So it was in between. A union is the opposite. X is either bigger than a number or less than a number, but never both. And I hope we'll see here when I talk about how to graph these that how that works. The difference is an intersection is both less than a number, whereas a union is either one or the other. Can't be both. Okay? So first thing we'll do is take a look at how to graph a union. And I just gave you a simple one here. We don't have anything to solve. It's already solved for x, but we're told that x is greater than 12 or x is less than or equal to 8. So just as all inequalities, we start on a number line. And we don't have to be too exact. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so if I start at x is greater than 12, it's an open circle. Greater than 12, it's going this way. And 8 has a closed circle. It's less than 12, so x is less than 12. And you can see the difference here. My intersection, they came together. It would have looked something like this for an intersection. We don't do that for a union. Okay, for a union, they are almost always going to go opposite. We'll see a couple examples where that's different, but most of the time they'll be going opposite like that. Okay, so that's what I mean when I say that it has to be one or the other. It can't both be, x cannot be here greater than 12 and less than 8 at the same time. It can't happen. So that's why we have a union in this case. If we look at one a little bit more difficult that we have to solve first, I'll have x minus 7 is less than or equal to negative 5, or x minus 7 is greater than 1. Remember, I can't write them together in a union. I always have to have the term or. But first we can start by solving for x here. And I get x is less than or equal to 2. Or if I add 7 on this side, x is greater than or equal to 8. Okay. Again, go ahead and graph these on a number line. 0, 1, 2, 3, 4, 5, 6, 7, 8. Less than or equal to 2, so it's a closed dot going less than. Greater than or equal to 8, closed dot going greater than. You see again they're going away where x has to be either bigger than 8 or less than 2. It cannot be both. Okay? But just as with intersections and with everything else in math, some things don't always work properly. So let's go ahead and solve this union and see what happens when we go ahead and graph it. So I'll subtract 4 to get 3x is less than 15. Divide by negative 3. What happens when I divide by a negative? I have to flip my sign. So x becomes greater than negative 5. Okay? If I solve the other side, I add 3 to start. 7x is greater than 21. Divide by 7. And x is greater than 3. Okay? So now we need to go ahead and graph these. I start with my 0, and I need to go down to 5, negative 5, 1, 2, 3. Okay, so at negative 5, let's see what's going on. Open dot on negative 5, and x is bigger, is greater than negative 5. It's going this way. X is greater than 3. So again, I have an open dot on 3, and it's going this way. Notice both arrows are going the same direction. And if I take this, the one on negative 5, and think about it extending forever, it's actually going to cover up this one down here over 3. So the only thing I have to write for my final answer is that x is greater than -5. Because if it's greater than -5, it also has to be bigger than 3. Okay? So that's one case where things might look a little different than a typical union. The other case, and the last example that we have here, is sometimes they tend to run together occasionally. So if I solve this union, just like I've solved everything else, -4x is less than or equal to 32. Divide by -4. What do I do when I divide by a negative? I flip the sign. Good job, guys. I knew you could do it. So I get x is greater than or equal to -8. Then I solve my other one by subtracting 12. 9x is less than or equal to 18. Divide by 9 and get x is less than or equal to 2. Okay? So x is greater than or equal to -8, or x is less than or equal to 2. We'll go ahead and graph these. 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. -8. We'll start down there at -8, see what's going on. Close dot because it's equal to, and x is greater than -8. So it's covering everything to the right all the way to infinity. Then if I look at 2, close dot, it's covering everything to the left. Okay? Now you might think this is an intersection, but it's not. And here's the difference. Let me turn it to this bubble thing so I can show you possibly a little better. Okay? Now this -8, we'll color it over in green, is covering everything bigger than 8, even things that are bigger than 2. So 3, 4, 5, infinitely. Okay? The one on 2 is covering everything less than 2 and less than -8. So -9, -10, -11, on to -infinity. Okay? Because it is a union, it has to be one or the other. It doesn't have to be both. We don't have to stop at the -8 and the 2 like we did in an intersection. Okay? That means, and I hope that we can see from this graph, that because it covers everything less than -8 down here and covers everything bigger than -2 to the right, that our answer is actually all real numbers. Okay? Because every single value is getting covered by this graph. Right? And yes, for those of you asking, if this happens on a test where it covers every single number and you don't put all real numbers, it is incorrect. This is your answer, all real numbers. Okay? You will miss about half a point, something like that. Probably make it a point since I'm pointing it out to you right now, that if you don't have it down there, it's incorrect. So that's all of unions. I hope we understood this. Next time we come back, actually I'm not sure what's next when we come back, but it'll be section 4. So hope these first 3 sections go well, and we'll see you guys in a bit. Bye.